All right, this review is going to go over the second part for the redox and acid-base reactions. We're going to start at number 2. We're going to highlight or circle all of the acid-base reactions. Remember, acid bases start with an acid. Any H molecule plus a base, which is any OH molecule, and it always makes a salt and water. So let's take a look. We have our acid, we have our base, we have our water, and NaF will be our salt. So this is an acid-base reaction. Next, we have a base. We don't have an acid, and we are not making a salt and water, so this one is not. Number 2, we have our acid. We don't have a base, and we're not making a water, so this one's not an example. D, we have our acid. OH is our base, we're making water, and MgCO3 will be our salt. So D is an acid-base reaction. E, we have OH as a base, H2S is our acid, we have K2S, which is our salt, and H2O, which is water. So this one is an acid-base reaction. F, we have H and O making H2O, but no salt. This is a synthesis reaction. G, we have a carbonate, we have oxygen. This is a combustion reaction because it's making carbon dioxide and water. And the last one, we have an acid, we have an OH base, we have a salt, and we're making water. So H is an acid-base reaction. All right, now we're going to determine if the following are acid, bases, or neutral. Litmus paper, it comes in a pink or reddish paper or a blue paper, and it'll test if it is an acid or a base. If that paper turns red or stays red, then it is an acid. If that paper turns blue or stays blue, then it is a base. A pH less than 7, that's what that symbol means, in case you forgot. If it's less than 7, it's an acid. If the pH is greater than 7, that's greater, then that is a base. And if it's equal to 7, then that is neutral. A sour taste is going to be an acid. A bitter taste will be a base. If the hydrogen or hydronium concentration is greater than hydroxide, then it is an acid. If the OH, the hydroxide, is greater, then it's a base. And let's write those down in case we forgot. That's hydroxide. And that's hydrogen or hydronium. Or hydronium. And then if they're equal to each other, that is neutral. All right, moving on. Label the pH scale below with strong acid, strong base, weak acid, or weak base, and neutral. Over here, we have our acids. They're less than 7. At the far end, we have our strong acids. And then we have our weak acids. Right in the middle, 7, that's where we have neutral. And then this is our base side. Just like strong acids are on the far side, strong bases are going to be on this far side. Strong base. So that means our weak bases are going to be right here between neutral and strong. Number 5, we're going to fill in the missing information using the pH equations. So on the first one, we're given pH. We need to find our hydronium ion concentration. And in case you forgot, I'm going to write that down here at the bottom. H plus is equal to negative sorry, it's equal to 10 carat negative pH. So in our calculator, we're going to type 10 carat negative 11.68. And that's going to be 2.89. So we're going to round that to 2.09. And this is the times 10 to the negative 12. Okay, next we need to figure out pOH. And we can figure that out with pH. So pOH can be 14 minus whatever our pH is, and that'll give us our pOH value. So we can do 14 minus 11.68, and that'll give us 2.32. Now to find the OH concentration, it's very similar to the hydronium concentration. We're going to do 10 with a carat negative OH. So 10 with a carat negative 2.32. If you ever get a number with zeros, we can always change it to scientific mode by hitting the blue second button, DRG, making it go under psi. And that's going to be 4.786, which rounds to 4.79 times 10 to the negative 3. And is it an acid or a base? Let's base it off our pH, 11.68. 11.68 will be somewhere right here, right in the middle between weak or strong base. So let's just call that a base. Next, we're given our hydronium ion concentration. So we need to find pH. And we're going to do that by using our negative log function. So we're going to type negative log, negatives under 3, negative log, and then we're going to type in 9.22 times 10 carat negative 8. That's going to be 7.03 times 10 to the 00. So let's get rid of scientific mode. That'll give us 7.035, which rounds to 7.04. Finding the pOH, we can use that formula again, 14 minus pH to give us that pOH. That's about 6.96. Let's find the OH concentration just like we did before, 10 with a carat negative OH. So 10 carat negative 6.96. Again, a lot of zeros. Let's change that to scientific mode. 1.096, so we can call that 1.1 times 10 to the negative 7. Is this acid, base, or neutral? Well, 7.4 and a 6.96 are very close to 7, so we're just going to call that neutral. On the next example, we're given pOH, so we can start by finding our OH hydroxide concentration. We're going to use the 10 carat negative OH. That's going to give us 5.75 times 10 to the negative 13. And then we're going to use our pH formula right here in the middle, but we're going to rewrite it. To find pH, we're going to do 14 minus pOH, and that'll give us our pH number. So 14 minus 12.24. Again, let's take it out of scientific mode since we have a 0, 0 power. Oh my goodness. Then we're going to do 14 minus 12.24, 1.76. Then we can find our hydronium concentration, 10 carat negative pH. Let's change that back to scientific mode. A lot of switching back and forth. That's 1.737, so we'll do 1.74 times 10 to the negative 2. Is it acid, base, or neutral? 1.76 is actually a very, very strong acid. So I'm going to actually call it a strong acid. All right, the next example, the last one here in this data table, we're given our OH concentration. So we're going to work backwards to find the POH. The formula for that is negative log OH So we're going to type in our calculator negative under the 3 log 1 times 10 with the caret negative 7, close that parentheses. That's about 7. Let's take it out of scientific mode. 7. Finding the pH, since we have POH, again, we're going to do 14 minus POH. 14 minus 7 is still 7. And then the hydronium ion concentration, we're going to use that formula, 10 with the caret negative 7. Change that back to scientific. That's 1 times 10 to the negative 7. And that will be neutral. And since this one's actually really neutral, we're just going to go back and call this one slightly basic. So I'm going to call that a weak base. All right, number 6. Acid-base reactions produce water and salt. They're always going to produce a salt. Next, predict the products of the acid-base reactions below and circle the salt that's produced. So we're going to switch the front ions. Na will switch with H. So that'll be HOH, which is the same thing as H2O, don't forget. Plus, now Na will be with PO4. Let's check our charges to see if we need a crisscross. PO4 has a negative 3 charge. Na has a positive 1 charge. So that means the negative 3 charge from PO4 will go down here for Na. So that'll be Na3PO4, and this one will actually be the salt. On our next one, we're going to have K switch with H. So H will now be with OH, so that's H2O. Plus K will now be with SO4. Let's check our charges. K has a plus 1 charge. SO4 has a negative 2 charge, so that means that 2 from SO4 will go over to K. And that will be the salt. Next, we have hydrogen switching with lithium. So now lithium will be with chlorine, and hydrogen will be with OH, which again is H2O. Checking our charges. Lithium has a plus 1. Chlorine has a negative 1, so there are no subscripts needed for this one. And the last one, hydrogen is switching with potassium. So now potassium will be with bromine, and hydrogen will be with OH, which again is H2O. Potassium has a +1, bromine has a -1, so there's no crisscross needed. And I forgot to circle the salts for the last two. There we go. All right.